This lecture is Introduction to Trees. Hello everyone. In this lesson we'll introduce you to an interesting data structure that got its application in a wide number of scenarios in computer science. And this data structure is tree. Tree is one data structure that is quite often used to represent hierarchical data. For example, we want to show employees in an organization and their positions in the organized hierarchy. Then we can show it something like this. Let's say this hierarchical organization of some company. In this company, John is CEO, and John has two direct reports, Steve and Tom. Steve has three direct reports. Steve is the manager of Lee, Bob, and Amy. Tom has two direct reports. Bob has two direct reports, and Sam has one direct report. This particular logical structure that I've drawn here is a tree. You have to look at this structure upside down, and then it will resemble a real tree. The root here is at the top and branching outward in a down direction. Logical representation of a tree is always like this. Root at the top. Okay, so tree is an efficient way of organizing and storing data that is naturally hierarchical. But it is not the only application of tree in computer science. We'll talk about other applications and some of the implementation details and how we can create such a logical structure in computer's memory later. First, I want to define tree as a logical model. Tree data structure can be defined as a collection of entities called nodes linked together to simulate a hierarchy. Tree is a non-linear data structure. The top node of the tree is called the root of the tree. Each node will contain some data, and this data can be of any type. In the tree on the right, the data is name of employee and position. So we can have an object with two string fields, one to store the name and the other to store designation. So each node will contain some data and may contain links or references to other nodes that can be called its children. Now I'm introducing you to some vocabulary that we use in tree data structure. What I'm going to do here is number these nodes in the left tree so I can use these numbers to refer to these nodes. I'm numbering these nodes not only for my convenience and not to show any order. Okay, as we were discussing, a node may have a link or reference to another node that we call its children. Each arrow in this structure here is a link. As you can see, the root node, numbered 1 by me, and again these numbers are not indicative of any order. So root node has a link to these two nodes, 2 and 3. So 2 and 3 will be called children of 1, and 1 will be called parent to nodes 2 and 3. I'll write down all of these terms I'm talking about. We mentioned root, children, and parent. In this tree, 1 is parent of 2 and 3. And now 4, 5, and 6 are children of 2. So 2 is the child of 1 and parent to 4, 5, and 6. Children of the same parent are called sibling. I'm showing siblings in the same color here. 2 and 3 are siblings, 4, 5, and 6 are siblings, 7 and 8 are siblings, and finally 9 and 10 are siblings. I hope you are clear with these terms now. The topmost node in the tree is called root. Root would be the only node without a parent. So we have quite a vocabulary here in terms of tree. Okay, now I'll talk about some properties of tree. Tree can be called a recursive data structure. We can define tree recursively as a structure that consists of a distinguished node called root and some subtrees. And the arrangement is such that the root contains links to all the subtrees. To T1, T2, and T3 are subtrees. Recursion basically is reducing something in a self-similar manner. This recursive property of tree will be used everywhere in all implementations and uses of tree. The next property I want to talk about is, in a tree with n nodes, there will be exactly n minus 1 links or edges. Each arrow in this tree can be called a link or edge. All nodes except the root node will have at least one incoming edge. Based on properties, trees are classified into various categories. There are different kinds of trees, used in different scenarios. The simplest and most common kind of tree is a tree with the property that any node can have at most 2 children. In this figure, node 2 has 3 children, so I'm getting rid of some of these nodes. Now, this is a binary tree. Binary tree is most famous. The most common way of implementing tree is dynamically creating nodes linked using pointers or references, just like we do for linked lists. We can look at this tree like this. In the structure I have drawn on the right, each node has 3 fields. One of the fields is used to store data. Let's say the middle cell is used to store data. The left cell is used to store the address of the left child. And the right cell is used to store the address of the right child. Because this is a binary tree, we cannot have more than 2 children. Programmatically, in C or C++, we can define node as a structure like this. We have 3 fields here, one to store data, and the data type is integer. I have filled in some data in these nodes. So each node we have 3 fields, an integer variable to store data, and 2 pointers. One to store the address of the left subtree, and one to store the address of the right subtree. We only have 2 pointers because we can only have at most 2 children per node. This particular definition can only be used for a binary tree. For generic trees that have any number of children, we use some other structure. Okay, so this is cool. We understand what a tree data structure is, but at the beginning we said about storing naturally hierarchical data is not the only application of tree. So let's have a quick look at some of the applications of tree in computer science. First application, of course, is storing naturally hierarchical data. For example, the file system on your disk drive, file and folder hierarchy, is a natural hierarchical data. It is stored in the form of tree. The next application, organizing data for quick search or insertion or deletion. A trie is used to store dictionary. It's really fast and efficient and is used for some dynamic spell checking. Tree data structure is also used in network routing algorithms, and the list goes on. I'll stop here for now. This is a good introduction to tree. Until next time, see you.